Today we are looking at using limits to define the derivative of a function. But before we start on that subtopic, let us quickly have a revisit of our parabola in grade 10 and 11. Remember, a parabola can be written in 3 different ways, which I have highlighted here so that we can quickly cover the example and be on time so that the megabytes to be used there is the minimum possible. Parabolas can be written as y is equal to ax squared plus bx plus ac, and we say when it is like this, it is in standard form. And we can also write the equation of a parabola as y is equal to a in brackets x minus x1 and in another bracket x minus x2. This is referred to as the x-cut form. And important is to realize that our x1 and x2 are the points where the graph cuts the x-axis. And finally, we have y is equal to a bracket x minus p, all that squared, plus a q. This is the turning point form. And the point PQ is the turning point of the parabola. I also want you to recall that the axis of symmetry of a parabola is given by x is equal to minus b over 2a, where the value that we get here for x is the x coordinate at the turning point, which we can substitute back into the function to get the corresponding y value. And as I said, today we want to look at we are now looking at an example to just make sure that we understand what is going on. Our first example reads, consider the function f of x is equal to 2x squared minus 5x minus 7. Consider the function f of x is equal to 2x squared minus 5x minus 7. The first part says, A, sketch f indicating the intercepts with the axis and the coordinates of the turning point. Quickly, I'm going to show you how we get the axis intercepts. In this case, when we are on the x-axis, the y is always 0. Therefore, it means the function 2x squared minus 5x minus 7 is equal to 0. You can factorize, and then we end up with x is equal to minus 1 or 3,5. On the y-axis, x is always 0, so y is minus 7. And as we looked above on the important things we need to recall, the x coordinate, the turning point, is given by minus b over 2a. So we substitute minus, our b is minus 5 over 2, which is that 2 times a, which is 2, which gives us 5 over 2 over 4, which when reduced gives us 1,25. This is the x coordinate at the turning point. We substitute into the function to get our corresponding y value, which means at the turning point we have 1,25 and minus 10,125. We were required to sketch this graph. So I want you to look at the curve. This is the x-cut, which is 3,5. This is the other x-cut, which is minus 1. And the turning point is 1,25 and minus 10,125. So this is the graph that we have sketched, showing intercepts. Remember, this is an intercept as well on y, and showing turning point. So all we are showing are the main features, and that is what we have done on this graph. Then the next question, which is part B, says, consider the point P with coordinates -2 and f of -2 and Q with coordinates 3 and f of 3. Part 1. If H is equal to 4, plot P and Q. Now, in this question, our P is not defined by H. Our Q is also not defined by H. So the 4 does not affect these coordinates. So we simply substitute our -2 into f of x and 3 into f of x to get the corresponding y values. And when you do that, you shall have your -2 and 11, and you shall have your Q with 3 and -4. Then part 2 says, determine the gradient of PQ. Determine the gradient of PQ. Now the gradient of PQ is defined by y at Q minus y at P all over x at Q minus x at P. Now we have these two. This is -4 minus 11. Then 3 minus -2, which gives us -15 over 5, which is -3. We are now on part C. Part C is saying, consider the points A, f of 1, and B, 1 plus h, and f of 1 plus h. Now we can see here, this is affected by h, and here it's not affected by h. So what do? We substitute in part 1. We are required to find or to determine the gradient, average gradient between A and B in terms of h. And that is what we need to do in terms of h. The coordinates of A are given by substituting 1 into the function, that is f of x is equal to 2x squared minus 5x minus 7. So we end up with our coordinates of A being 1 and -10. We also need the y value when x is 1 plus h. So we substitute and we simplify as is indicated. We end up with 2h squared minus h minus 10. Now we are looking for the average gradient. So the average gradient of AB is f of x, f of 1 plus h minus f of 1 all over 1 plus h minus 1, which reduces to that and ends up with that. Then we factorize our h, and the h cancels out. We remain with 2h minus 1. This is the average gradient between the points A and B. Now we are moving on to look at part 2. Determine the average gradient between A and B if h is equal to 4. Part 2, our h is equal to 4. But in part 1, we calculated our AB in terms of h, which is 2h minus 1. So if h is equal to 4, we substitute a 4 where there is an h. So it's 2 times 4 minus 1, which is 8 minus 1, which gives us 7. This is our average gradient between A and B. Part 3, it reads, if h is equal to 4, plot A and B on F and draw a line passing through them. If you come here, you will notice that the original graph that we had, we are talking about points A and B. Here is my A. Remember, your A is 1 minus 10, so this is your A. And your B, according to what we have, is 5 and 18, so this is your B. So we just draw a line. The red graph is what we are talking about. Enough of that. Part 4. Part 4 reads, use your graph to determine the gradient of AB. Now we want the gradient of AB. Our coordinates for A are 1 and minus 10. B is 5 and 18. So using the gradient formula, we have 18 minus 10 over 5 minus 1, which gives us 28 over 4, which is equal to 7. Then part D is saying, consider the points D with coordinates x and f of x, and E with coordinates x plus h and f of x plus h. Part 1, it reads, determine the average gradient between D and E in terms of x. Now, as usual, our definition for part 1, our definition of f of x is 2x squared minus 5x minus 7, which implies that at D, the coordinates are x and 2x squared minus 5x minus 7. Then we are looking for f of x plus h. F of x plus h is defined by substituting wherever there is x, we now place in x plus h. So we shall have that. You square that, you get that, and you simplify, you end up with that long expression. This is the y coordinate at the point x is equal to x plus h. So our E has coordinates x plus h and 2x squared plus 4hx plus 2h squared minus 5x minus 5h minus a 7. Substituting into the gradient to get the gradient in terms of x, we shall have gradient of dE equal to, you take this whole expression, write it here, minus, you take this expression, but make use of brackets because the signs we have to change. So when you simplify, you get that. Some terms will cancel out. We remain with 4hx plus 2h squared minus 5h all over h. Now when we factor out our h, we shall see that the h will cancel out and our solution will be 4x plus 2h minus a 5. This is part 1. We are now looking at part 2. We are now on part D, part 2, and it reads, determine f dash of x equal to limit of f of x.
Yeah.
We are now answering part D, part 2, determine f dash of x, defined by limit as h goes to 0 of h of x plus h minus f of x all over h. So all we are doing now is to substitute what we already have. So we shall have f of dash of x is equal to limit as h goes to 0 of this expression. This expression is what we found in part 1 of part D. So we're substituting 4x plus 2h minus 5. But h is going to what? To 0, which means this is now 0. We remain with 4x minus a 5. Part 3 says, determine f dash of 1,25 and explain your answer. Now we are talking about f dash of 1,25, which is equal to 4 multiplied by, we are here substituting for x, 1,25 minus 5. It will be 5 minus 5, which gives us 0. This is the gradient of the turning point. This is the gradient at the turning point. At the turning point. And is not an average gradient, because this is now a tangent passing through one point. It's no longer average gradient. It is now the gradient at the turning point. And what I need you to also understand is that when we are talking about the gradient of the turning point on a parabola, it is always horizontal. Therefore, it is always in terms of y, because it will be y is equal to some constant. And this, as I discussed with you in the other lesson, is always a horizontal line. And it only cuts the graph at that particular point. Thank you. But before I exit, I need you to do this and that. We are ending here. So you are doing this and the other one, which I will also post for you to do. Thank you very much.